We're on the campus of the Crystal Bridges Museum of American Art, standing inside our Buckminster Fuller's Fly's Eye Dome. This is a 50-foot version of a design that he developed in 1965. It is incredible to be inside it, surrounded by this fiberglass structure with these oculi that perforate the entire surface, framing the sky, the clouds, and the trees.
Well, it's called a fly's eye dome because unlike the geodesic domes, which are based on the form of a triangle, here we have a dome inspired by the eye of a fly. The idea was to create ideal housing that would be inexpensive and efficient.
Our Buckminster Fuller famously asked architects, how much does your building weigh? That's not something that we ever ask. We ask, how tall is your building? What is the square footage? But to ask the weight of a building is to get at the issue that maybe there's a way to reconceive of architecture in a way that is much more responsible with the finite resources of the earth.
That's a question that was only really possible to ask at the beginning of the 20th century when there were new technologies that made it possible to rethink architecture.
Which was done most famously in Germany, especially in the wake of the First World War, when there was tremendous demand for housing, but also new industrial processes that allowed for the mass production of elements that would then be fit together on site.
It was a new way of thinking about design. We can think about Le Corbusier talking about the home as a machine for living. The idea of designing every component to perfectly suit its purpose, much the way an airplane has to serve the purpose of the person flying it.
Le Corbusier, Mies van der Rohe, Walter Gropius were all grappling with the idea that houses in the early 20th century were still being made by individual carpenters in the way that they had been made throughout the 19th century, not taking advantage of industrial materials and industrial processes. But our Buckminster Fuller goes far beyond what these architects ever envisioned. He was thinking about architecture as a kind of engineering problem.
Fuller wrote, "The success of all humanity can be accomplished only by a terrestrially comprehensive, technologically competent design revolution."
This is really a theoretical statement. This is not a house. When it rains, it gets wet in here. But it is a conceptual model that is specifically made for a house. And Fuller conceived of this structure as being made into a house. So each of these oculi would be covered in a variety of different manners. They could let sun in to warm the house. They could be made opaque to reduce the radiation of heat outside. They could include wind turbines as well as solar panels. There could be a water collection system so the house could be completely self-contained.
Within this dome, the oculi are pervasive. They take up so much of the surface area of the structure. When I think about the history of domes, I think about one dome over a building, for example, the Pantheon, and that dome required thick walls of concrete to support it. Or I think about the dome of Hagia Sophia, which does have a ring of openings around it, but again, massive piers to hold up that dome.
Our Buckminster Fuller's great insight, I think, was that architecture needed to leave behind its tradition of compressive strength and to replace it with carefully designed forms that would take advantage of tensile strength. This was the origin of the geodesic dome, which this is in turn based on. Our Buckminster Fuller spent his childhood summers on an island in Penobscot Bay in Maine, at a house with no electricity, with no running water. That is to say, he spent his summers investigating nature. And he said that his innovations were all based on the careful observation of nature.
The geodesic dome and this fly's eye dome seem so modern and futuristic, and yet what he designed is now decades and decades old.
Buckminster Fuller is very much a product of the late 19th and early 20th centuries, and yet he does still seem so modern, so contemporary in his thinking. And he had some successes and some failures, famously the Dymaxion car and then the Dymaxion house, neither of which were ever put into mass production, but both of which came quite close. And ultimately, he would have significant success with the U.S. military, which used his geodesic technology, and perhaps perhaps most famously is the enormous dome that was at Montreal Expo. But then there was a real revival of R. Buckminster Fuller's work in the 1960s and 1970s that coincided with the Back to the Earth movement, with communes, with counterculture.
He's the one who came up with the term spaceship Earth. And this idea inspired the whole Earth catalog, which featured on its cover an image of our beautiful blue planet from afar, which we had never seen before. But the idea of humanity as a whole, a very utopian idea that together we could solve mankind's problems with the right engineering and the right design and the right technology.
And a number of people took this on individually and in collectives. Famously, the commune in southern Colorado, Drop City, as well as numerous dome projects in California and throughout Colorado and the rest of the United States and other parts of the world, all of which goes back to Buckminster Fuller's innovations. His understanding that with a minimum of materials, one could build an extraordinarily strong structure, and that there were enormous cost efficiencies that were possible through this technology. There were really no bounds to his imagination. He was thinking with a kind of universal scope, which he felt was necessary to save mankind from its excesses, from its greed, from its privation.